exercise 13.4. So now this whole exercise is based on my frustum, right? Now first you have to understand what is frustum, correct? So frustum, we have done all the combination of solids, right? We in the last few exercises what we did was we were combining the two figures together, like hemisphere and then a cone over it, or a cuboid and or cube and some hemisphere over it, or ice cream cone, right? So there was an ice cream cone and then hemisphere over it, right? So this is how the ice cream cone looks. So we had been doing the addition of two figures. Now let's do some subtraction of two figures, okay? So or by cutting. So one of the thing is like we have to suppose I have a cone in this form and I will be cutting it, right? So if I cut this volume, then what do I get? I get two parts, right? So I get one small cone and I get this kind of figure here, right? So this is basically a small cone cut out of that, and here this figure is called as the frustum. And we see the examples of frustum in lot of day-to-day use. We have the buckets in the same shape of frustum. Then we have some kitchen utensils. We have a lampshade or glass. Yeah, mostly all the glasses are in the form of frustum. So these are few examples. So now we just have to see that the radii are different of top and bottom. So this radii may be R1 and this radii may be R2. So there are two different radii, correct? So then there are formulas for volume and surface areas. Let's move to next exercise now. Number 1 says a drinking glass is in the shape of a frustum of a cone of height 14 centimeter. The diameters of its two circular ends are 4 centimeter and 2 centimeter. Find the capacity of the glass. So capacity means we have to find the volume. Okay, so let's draw the diagram. It is a glass. Okay, so my glass would be like this, right? Okay, so now let's write down the dimensions. So dimensions would say that height is 14 centimeters. So my height is equal to 14 centimeter. The diameter, okay, are 4 and 2. So this is radius will be 2 centimeter and this radius will be equal to 1 centimeter, right? So this radius 1 I can say for the top one and R2. So these are my two radii, and height is this, right? So this is my height is 14 centimeter. Okay, I have to find the volume. Okay, so now let's write down the formula for volume. So volume of frustum, right? So volume of frustum is equal to 1 by 3 pi into h into r1 square plus r2 square plus r1 into r2. Okay, so that's fine. Now let's substitute the values. So now we have volume is equal to 1 by 3 into height is my 14 and pi is 22 by 7, and this is equal to 2 square plus 1 square plus 2 into 1. Okay, so now I get 7 and this is 2 times and 1 by 3 into 44 and this becomes 4 plus 1 plus 2. So now next step I get is 1 by 3 into 44 into 7. 7 4 times 28, 7 28 and 3 by 3. Okay, so this is equal to 3 1 times 2 by 3, or I can also write down this as 102 and 0.67. I know it will go 6666, but then approximately and rounding off we get this one. And unit would be, everything is given in centimeter, so centimeter volume cube, right? So that would be my answer. So now question number 2. Question number 2 says the slant height of a frustum of a cone is 4 centimeter and the perimeters, that is circumference of the circular end. So they have not given the direct radii directly, they are giving the circumference. So circular ends are 18 centimeter and 6 centimeter, right? Find the curved surface area of the frustum. Okay, so now this time we have to find out the curved surface area. So now let's put the data. So now I think the top one is like this, and I can have the frustum like this, right? So now the slant height of this frustum is 4 centimeter. Okay, so L is 4 centimeter. Instead of height, they have given the slant height directly. And the perimeters of circular ends is 18 centimeters. So here my pi r square, right, or 2 pi r. So perimeter, circumference, right? So 2 pi r is equal to 18 centimeter, and here of r1 I can say, and this is equal to 2 pi r2, which is equal to 6 centimeter. Okay, so I have put all my dimensions here. Now I can say that I have to find the curved surface area. So formula for curved surface area I can write down. So my curved surface area of frustum is equal to pi into L and R1 plus R2. L is given to me directly, so I don't have to find out. So that is making my work easier. And pi is 22 by 7 and L is given as 4. Now R1 and R2. So 2 pi R1 is given as 18, right? So now I can write down this as R1 will be equal to 18 by 2 pi and R2 will be equal to 6 by 2 pi, right? So I have derived from this and this. So that's fine, I think. Now let me write down pi only, because that will get cancelled with the other one, into 4, and this becomes 2 pi is the LCM here. So 18 and 6 is 24. So 24 by 2 pi. Pi and pi will get cancelled here, and 2. So okay, here only I get, so this is equal to 48, and curved surface area, so centimeter square. Question number 3. Question number 3 says a fez. It is the cap used by the Turks, right? So it is shaped like the frustum of a cone, and your figure is given in the book. If its radius on the open side is 10 centimeters, so open side will be the bigger one, right? We can figure it out, the cap. So top one will be smaller, and we can see the diagram also. And radius of the upper base is 4 centimeter, and its slant height is 15 centimeter. Find the area of the material used for making it. So we know area for the material used will be my curved surface area plus area of the top, because it is closed at the top. At the bottom it is open, correct? So let's draw the diagram first. So it is like this. Okay, let's put the data. So it's shaped like the frustum, and its radius of open side. Okay, so radius of open side, this side is 10 centimeter. Okay, and the radius of the upper base is 4 centimeter. So this is 4 centimeter. right? Now I think I can take both of them as r1 and r2. So this I can take as r2 and this I can take as r1, right? So I would say area of material used, okay, this will be equal to curved surface area of frustum plus area of closed top, I can say, right? Area of closed top is closed in this case, correct? So now let's put the formula. So now area of frustum will be, curved surface area is pi L is given to me directly, into r1 plus r2, and closed top means r2, right? So plus pi r square, and this is my r2 here, what I have marked in the diagram. So this is equal to, pi is common, I can take like that, and big bracket, length is equal to 15, and this is equal to 10 plus 4, and plus pi already I have taken out, and r2 is 4 into 4. Okay, now this gives me pi, I'll keep it like that only, and this is equal to 15 into 14 plus 16, right? Okay, now I have pi and 14 5, so I have 70 and 210 plus 16. Okay, so now I can write down 22 by 7, and this is equal to 226, right? Okay, now this would be equal to, now I have to multiply this by 226. So I can say, okay, this is my rough column, I can say here, and this would be like if I double it and then I just have to put it, so I'm just trying to shorten it. This is equal to 4, and 26 double will become 52. So 452 and 452, this is I'm multiplying 226 by 22, so 2 7 9 and 4, then I have to divide by 7. Okay, so 4972 divided by 7, so this I get as this is my rough. Okay, then I have 7 times, right? 7 49, and then 7 one time, and then 0 and 20, so decimal point, 7 2 times 14, and then I get 60, so 7 8 are 56, something like that. So that's fine, I think. So that I'll just stop it here. So centimeter square. So my area of material used, I can write down here only the answer, or I can just write down in a statement also. Area of the material used, the area of the material used is 710.28 centimeter square. So rest 2 questions of this exercise in the next video, guys. See you.